We're also going to be running 12 volts of current through it at, well, a lot of amps. The amps are basically controlled by the amount of electrolyte that we put into the water. But we'll get into that in a little bit. We need to now add on a gauge set. What do you say that is? It's one of these little units. Of course, I made it custom. Now, what we have here is an airflow meter from a welding machine. What we also have here is a volt gauge and an amp gauge. We want to know what our voltage is. We want to know what our amperage draw is so we don't kill our battery or overheat the system if we're drawing too many amps. Amps is the killer here, not the volts. So now, we're going to take our tube from the airflow and we're going to put it into our bubbler. Now we're going to take the two leads. Remember, red is positive, black is negative, and we use, of course, stainless steel nuts to put it all together. So now, we have our electrical hookups all together nicely. And then with our other two leads, pretty thick wire, it's hard to handle, so it looks a little awkward. So these are connected. Now we're going to take our negative and positive, put it to our battery. That's right. Clip it on here. Oh, look. We've got voltage. Show you again. Unplug it. Plug it back in. We have 12.5 volts. It's a good battery. It's what we need. As you can say, well, why did I hook it up? The thing's not even full of water yet. Well, we need to test the system, make sure our connections are right. We have voltage, no current. We shouldn't have current. We don't have a solution in our tanks yet. So now we have our connections. Now we need to put some electrolyte in here in our aqueous solution, the technical term, and we need to fire it up and see how much current we draw. We don't want to draw a lot of current, 15 amps per unit, but you'll have to wait for the next